Just a quick summary of what we'll be covering through this webinar. So we'll be talking about who we are as Jacobs within the industry. We'll be looking at the challenges the industry faces and how Flood Platform can support overcoming these challenges. We'll give you an overview of what Flood Platform does before I do a live demonstration of the system. So I'll be showing you different model types, different functions within the software using real-world data. I'll then also have a quick look at the roadmap, what functions are coming soon, as well as some case studies where Flood Platform has allowed us to deliver projects which wouldn't be possible without this software. I'll then hand back to Richard, who'll be talking about the licensing model and pricing for Flood Platform before finally we have some time at the end for some questions and answers. As Ollie said, if you do have any questions, please pop them in the questions box and go to webinar and we can work through those at the end of the webinar. Can I hand back to you, Richard, to talk through the next few slides?
Yes, thanks, Adam. So most of you, well, a lot of people know Jacobs for the consulting services that we do. Could you go on a bit more, please, Adam? We do a lot of consulting work across the world. We've got over 1,200 modelers that do modeling with our own product like Flood Modeller. We also widely use TUFLOW, HECRAS, SWIM, Mike, InfraWorks, ICM, InfraDrainage, all of those that we use to deliver our work. And in fact, we are the largest consumer of InfraWorks and Mike software across the world. So we live and we breathe modeling, and in fact, it's something that we love doing. Okay, but in addition to that, we've got over 800 staff who focus purely on digital and data type of work, whether that be data science, product development, product services, all around the digital world. So we're a large organization that not just do the consulting work, but also the software development in the water area. So we've got a development team purely dedicated to our flood products, around 32 developers currently working on our portfolio of products, in addition to the sales and marketing team. And for Flood Platform, although it's fairly new to market, it's actually been around for more than 15 years. It's underpinned a lot of the delivery work that Jacobs has been doing, and it's only recently that it's become available, and we've turned it into an external product. Overall, Jacobs has been developing flood modeling products for more than 50 years. Many of you will know about Flood Modeller, and it's got a long history and pedigree of use, not just in the UK, but across the world. We believe this combined kind of software development and consulting service and use, and the large resource that we got, puts us in quite a unique position to have detailed insights of the problems and challenges people face and how to innovate and drive the industry forward with solutions like Flood Platform. Next slide, please, Adam. So a few years ago, when we decided that we were going to, or exploring whether we made Flood Platform available for everyone else, is we did some market research. We did a deep dive, not just to our users in the UK internally, but externally as well, and everywhere else across the world. And we did extensive interviews, surveys, and exploration work. And the messages that we got back were basically around these key themes: is that model and data management is a big problem. Okay, looking after your models, storing them, accessing them, getting hold of them is a bit of a challenge. But actually transferring your models from one person to another, whether it be a team internally to work on something, or to a client to review things or deliver at the end, was quite a challenge because of the size of the files and making sure that you included everything that was there. Undertaking checks and quality reviews by your subject matter experts or your managers, technical directors, etc. Also a challenge because they've got to have access to all the files, the latest files, and make sure that everything's there. And then also when they're doing that, it's all about making sure you've got the right tools and the visualization stuff available to be able to interrogate and look at the data. And when you're sharing it, to be able to kind of understand what you're looking at and where you're looking at. We also found that there's a lot of people trying to automate a lot of the analysis, which is great, but teams within the same organization were trying to do the same thing, but in different ways. wasting a lot of time and effort in duplication, but also version control of those things. And as software products evolve, it's constantly having to update those tools because they quickly become outdated. Another thing that has always been a challenge in modeling is collaboration and getting feedback on your modeling results. In Jacobs ourselves, we used to use spreadsheets and Word documents to be able to provide feedback and have a bit of a track record. But when you're doing that externally, there can be huge problems of collecting that information from multiple people and knowing what you want to act on. And then finally, for a group of people, actually getting access to computers and licenses is a problem, especially when you've got deadlines and you've got lots of simulations to do in a very short time. And as we move to things like probabilistic analysis or doing lots of climate change analysis, more and more analysis needs to be done, and the simulations take longer and longer. And getting access to the hardware and software is a challenge. When we took all this together, we realized, well, actually, Flood Platform solves most of these problems, which was why we decided we would turn it into an external facing product. Next slide, please, Adam. So when we were creating Flood Platform for the external audience, we looked at who we needed to design it for, who were the people who were going to be using it, so we could make sure the user interface and the workflows was tailored to those people. So the first group is the flood modeler themselves, the obvious group of people, and they've got particular needs. But when we start looking at stakeholders and senior technical managers, they have different needs. They don't need some of the complexities of modeling. They just need to know clear information and be able to easily access and easily use that information. Then if you look at the flood risk manager or the planners, they have different needs. They have less desire to understand all the technical detail, and it may be the results and access to the results and making sure that they've got the latest information and how that impacts certain decisions is more important. So in the whole, we've been looking at these 5 key personas, as we call them, to make sure the Flood Platform works for all of them. Adam, back to you, I think. Oh no, sorry, we got one more for me. I apologise. So to try and explain how Flood Platform is configured, if you take the 3 cubes at the top, you've got your clients who you might be working for. You've got the modelling teams that are working on it, and you've got your stakeholders who are also interested in the outputs. And those 3 groups of people can all access the same platform. Whether it be for managing the models and the data that goes within them, to visualizing the model data files or the results for those files or model simulations, whether it be for collaboration and making sure that you're providing feedback and you're all working together on the same data set. It also provides security for all of that, so you can control access, who has access to what and what particular parts of a model or files. It has all the simulation and analysis building blocks there. And coming soon, it's not there today, but it will be there as soon as detailed reporting to help you kind of produce your modeling outputs and help you produce your modeling reports. Underneath all of this is obviously storage. Modeling files take up a lot of space, and we deal with that, providing elastic storage, and also compute, whether you're wanting CPU or GPU compute. We've optimized the compute to enable you to scale rapidly and cost effectively. At the moment, the external version of Flood Platform works with Flood Modeller and TUFLOW. We will be adding HECRAS and EPA Swim very soon. They already work with the internal versions that we've been using for many years. And we will be adding also other modeling platforms soon as well. But overall, it is designed to be one platform to unify all modelers to enable you to do all of these activities in the central location. Now it is over to Adam to give you a bit of a demo.
Thank you, Richard. Thanks for that great introduction, and I must say I can associate strongly with a lot of the challenges faced by modelers. So I'm going to give you a bit of a live demo. What I'm going to show you is how the system works. I'm going to show you how you can manage your model data within Flood Platform. I can visualize your data, how you can share your data, initiate simulations, and a whole host of other features. It's really challenging to get everything into one short demonstration. So Flood Platform is entirely web-based, so you log on via a web portal. So you log on using two-factor authentication, which I've done already, and you land on our landing page. And this is where you can start jumping into your models, start to upload data, interact with data, no matter which of those personas Richard talked about you are. So I've landed in my space, and down the left-hand side, I've got access to various spaces I can store model data. I've got my sandbox, which every user has, and that's where you can store data you don't want to share with anyone else. It's a scratch environment you can work in. And beneath that, I've got access to an organizational storage account for both Jacobs UK and Jacobs Australia. And this lets me interact with different organizations. So if I was working with a sub-consultant, I could create an organization that they could interact with as well. It may be I'll be given access to a client's organization as well, so I can access their model data. And these will all appear down the left-hand side. Down the bottom, I've also got access to my settings panel, which I'll jump into a bit later on. On the right-hand side of the screen, I've got access to all my model data. And there's two ways you can access this. You can access it via these tabs, these panels on the right-hand side, or via the global viewer. And I'll show you that global viewer in just a second. Just to explain how we organize model data, and it'll become more clear as I work through the demonstration. All model data is associated with a project. So that could be an individual study or an individual commission. You can also group your projects into team spaces, and that's what we've got down here. So we've got a series of team spaces, and these could be a team space for a particular client. It could be a team space for a particular project team. So it could be the Manchester modeling team space where they save all their projects, or it could be a team space, say, for an individual framework where you've got various contracts or call-offs being provided by one client. It's up to you how you do it. But you'll notice that each and every one of the team spaces has a spatial location element to it. So it helps you find your projects. So I jump into this one here. You can see you've got individual projects underneath this team space. And you've got, and sorry, to refresh that quickly, you've got multiple projects under that single team space, and they've all got a spatial extent that really helps you find those projects. We've got global viewer. So up here on the right, we've got this little button here, and that will jump you into our global viewer mode. This recognizes it's a real challenge in the industry to track down your data, to find where you've done work in the past. So if you're a consultant, where have you worked in the past? If you're a client with a large data holding, where is your project data? And what this lets you do is interact with the map to find your projects. So you can see we've got lots of projects in the UK. We've got lots of projects in Australia as well. I want to say, find if I've done any modelling work in Clevedon, which is a town in the southwest of England. I can search that out. I can search by location and zoom in, and there we are. So we're in Clevedon, and I can see I've got a modelling project available to me. I can also see I've got modelling projects to the north up in Portishead, another one down in Western-super-Mare as well. And I can click on that, and I get high-level information about that project, and I can then jump in to those project details. This is a really flexible interface. I can search in a number of different ways. I can search by tags or project information. I can search by geographic location, or I can just pan around to find what I'm looking for. It's also worth noting this environment is 3D enabled as well. And so what we're looking to do in the future is allow you to visualize your results directly in this 3D environment, which gives you a really nice way of visualizing your model data. If I jump into the details of that particular workspace, I can see I've got these several projects. So this may have been a commission to undertake coastal modeling across several locations. So I've got 3 projects. I want to jump into this Clevedon one. I can see I've got some TUFLOW coastal modeling going on here. When I delve a little deeper, I've got the individual models themselves. So these are models that have been uploaded by various members of staff over time. And at this location, it's really easy to add models. I simply click upload, and I've got an interface here, and I can choose the model I want to upload and click OK. I won't do that live, even with a few hundred megabytes. It could take a few minutes to upload very large files. So I want to just use the data I uploaded earlier. It's also worth noting before I move on that if I jump back to that, I can access data about the team space or individual projects, and this allows me to restrict who can access these models as well. So I've got this high level information, the spatial extent of this project, but I can also access members. So I can add new members in here, or I can adjust the permissions of those individual members, whether they're owners, admins, viewers, or other. And this gives me granular control over who can do what. So if I add a member as a viewer, they can't upload new data, they can't initiate simulations, but they can view the results. And if I allow them, they can download the results. And this is really good. So looking back at those personas, it's understandable if you want to add other modelers into your team, you want them to be able to run simulations and upload things. Whereas if you're sharing with, say, a flood risk engineer, you may just want them to be able to view results. Or if you're sharing externally with a client or stakeholder, you may again just want them to be able to view results, and it's your choice whether they can download them. Also in the team space settings, I can access the utilization. So it's always important to know what you're doing and how much space you're taking up. So you can see in this case, this model is fairly small. It's only 3 gigabytes in size. It's not taking up much space. And it's used a bit of compute to process the simulations, or someone's run some simulations within there. So jumping back into that model, I choose version 5. And from here, I can interact with the data uploader. So I've just updated a zip file which contained all my model files. This is a pain point for many modelers because often you don't know what's in that zip file. Has someone can create it properly? So the first thing I do is I can look at my model checks, and on upload, what we're doing is scanning the files for anything that's missing. So in this case, I identified a few missing files which I need to run my models, and it helps me understand, have I got everything I need? I can resolve some of those challenges. I can also manually look through the model files. So in this case, this is a pure TUFLOW model. So for instance, I can look at the TCF file, and what we do is we apply syntax highlighting by default so you can understand this model. There's also a batch file that comes with it, so you can see how that was run with the different wildcards used within the model. I can identify access the other data like the TGC files and the boundary control files. One nice thing is when you're looking at things like CSVs, if we think it's tabular data, we'll display it as tabular data rather than the raw CSV, so it's a lot easier to interpret. So in this case, these are the tidal boundaries applied to the hydraulic model. If I just jump back again and go to simulations, when you upload a model to Flood Platform, it's doing a lot of stuff behind the scenes to identify your simulations. So in this case, I uploaded a single TCF, but with a batch script, which converted that into multiple simulations. We recognize that's for if you're looking at the raw data, that's not terribly easy to interpret. So what Flood Platform's done is it's broken out all those individual simulations, and it's automatically tried to classify those based on the file naming and other data we have. So in this case, it's done a really good job. It's identified I've got a range of defended and undefended simulations, and it's assigned AEPs to these as well, so return periods. So without me having to dig through the model log file, all their information, I already know what these simulations are. And if there were future climate change data as well, that would be populated. And what you can see that most of these simulations have been run, but some either haven't been run or they've got partial results. There's some problem with the data that was uploaded. I'm just going to jump into a model that has run successfully. And when you go in here, what you get is a summary of that simulation. So this is really good for understanding this data. Normally, this is quite complex data that's saved as CSV files and other formats. We're processing that data. So you can see at the top what the solver was, when it was run, what type of simulation it was, in this case, a classic. You can see the key information about that simulation, so number of wet cells, mass balance, and so on, and that's tabulated here. You can also access the input data again, so you can see the TCF file that was used to initiate that simulation, and access the log file, so you can access the TLF file to see how that model ran, and you can delve into the detail of what was going on with that simulation, as well as some high-level overviews of any processing or upload issues are identified. From here, you can also delete the run, export the simulation, or rerun the simulation if you want to, and I'll show you that in a bit. But the nice thing is you can jump into the simulation. So if I, click on that and just open that as a new tab, what I can do is actually view the results of that simulation within the web browser. So I don't need specialist GIS applications to do this. So this is my simple Clevedon model. I can zoom out a little bit and see where I am. So this is the Severn Estuary, this is Clevedon, and we're looking at coastal flood risk. I can look at the model components. So for instance, I can see the code layer. So that's the extent of the 2D model. Tidal boundaries were applied. So you can see green lines where the tidal boundaries were applied. I've also got some defence data on there, which is sat underneath the boundary, and some PO data as well, where some plot outputs have been generated. So it's not quite a nice way of visualizing the data. I'm just going to leave the boundary on and jump back to results. And normally to look at these results, you need some specialist GIS applications like QGIS or ArcGIS, but you can look at the results all within Flood Platform. I'll show you this for a 2D only model, and I'll look at some 1D, 2D models in a minute. So when I switch on the depth grids, I can choose to see the maximum extent. So I can just flick straight to the maximum flood extent, or I can visualize them over time. So I'm going to jump forward a little bit to where we start to get some flooding. And then I can time step through this so I can see the progression of the flood risk across this area, all coming out that tidal boundary. I can also switch on the vector arrows as well, so I can see the direction of flow. And this is really helpful for understanding the progression of the flooding in this area. You can understand how that flooding has evolved, and it's really useful to communicate information to clients, to stakeholders, better than static maps. You can pan and zoom around this. It means something. You can switch the mapping, so you can switch to some aerial mapping if you want to, so you really understand what's going on within this model. What you can also do with this is you can bring in the check files. If I switch back to that mapping, for instance, I can bring the grid checks, so I can understand how the model's been set up and how it functions. I can bring in the various of the checks and the log files as well, interact with those, and really understand my model all within a web browser. The other nice thing I can do is I can start to put comments on this. So for instance, you can see someone's already been in here and they've added spatial comments. So click on here. So that's where I used to live about 20 years ago. And you can see that's its significant flood risk. But also here I can see there's some glass walling going on the edge of my model, and that may be something you want to review. So if you send this to a client, it's really easy for them to comment on your models, and it aids that interaction between clients, stakeholders, and suppliers. And to add a comment is really easy. I just click where I want to put my comment, and I can write what I want to send back to the consultant or whoever's provided that model. Just jumping back to that simulation, those simulations, you can see that some of these haven't been run, and I may well want to rerun these. So I may want to run things off platform and import them, or run them on the platform. It's really easy to do that. I just choose the simulations I want to run. So I'm going to run these 3 partial simulations and click Add to Queue. And you can see they've now jumped over to my run queue over here. When I come into here, the software is checking that we've got all the data to run those simulations. So it's checking all the relevant files are available, all the boundary data is available. And so it won't let me run those unless they're ready to go. I can then say, okay, I'm ready to go, and click Run Selected. So in the back end, the system will spin up resources in order to run those simulations. It knows whether it needs GPU cards or a CPU, and it will run those simulations in parallel and let me know when they're complete. This model takes about an hour or 2 to run, so I'm not going to do it live. But if I want to, I can do that, and I get detailed reporting on how the simulation is progressing, so I can track the progress in real time. Once the simulations are complete, they come back to me, and I can use them in the same way I did with the pre-run simulations. Just having a look at some other types of models. That was a simple TUFLOW model. Let's look at something a bit more complex. So this is a linked Flood Modeller TUFLOW model of Upton, which is on the River Severn. So again, I've got all my model checks and model files, but in this case, I've got some Flood Modeller data as well. So I've got my Flood Modeller models, my event files, as well as the TUFLOW data. If I jump into simulations, you can see I've got 3 simulations run, and again, the software's had a good go at identifying there's no scenario specified, but there are different return periods here. So I'm going to open up the 100-year simulation. These will run off platform. So what you'll see is we don't have, for the Flood Modeller component, we've got the standard Flood Modeller bitmap showing me how the model performed, and I've got the summary data down here. I've also got the same for TUFLOW, because this was run, the TUFLOW data is richer. I can look at this, and this was a HPC model, so I've got the control number data there as well. I've also got the input files, and because this is a linked model, I've got both a summary of the IEF file, the Flood Modeller control file, and the TCF, which was the TUFLOW control file. Same with the logs. I could access either TLF, which is the TUFLOW log, or the Flood Modeller ZZD log, all in one place. I'm now going to just jump into those simulations So this is, I'm going to show you in this both the 1D and the 2D component. So this is a linked FM TUFLOW model. Let me just switch on a few more bits so that you can start with, you see the 1D model only. And when I zoom in a bit on this, it changes to the standard Flood Modeller icons. And what I can do is I can click on any of these and I can see the results immediately. So this was a flow boundary, so I can see the flow introduced to the model and the water level as a result. But with cross sections, I can see the cross section profile, the water level, so the maximum water level, as well as the starting water level in the model, and also the flow and level data calculated there. And that's the same for any flood modeler unit. So I can carry on doing that. What's really nice, I can also detach this. It doesn't show very well on a presentation, on a screen share, but I can detach this and have this as a floating window, which I can have off to one side, or I can redock it within Flood Modeller, which gives me a lot more screen space to play with. This model also contains some estuary networks, some pipe networks, which are down here. So this is an estuary pipe through an embankment. If I click on that, this was a pipe, and I get details of that, what that pipe looks like, and again, the flow and level data. So it's a far easier way of interacting with the data than using a GIS application. It's immediately available to you. I can bring in the other model components. So let's bring in the boundary links. So you can see there, that's the 1D, 2D link lines have been brought in. I think that'll do for now. I can also bring in the Z lines. So in this case, I've brought in a series of embankments down here. So you can see I've digitized embankments. And I've also got property data brought in as well. I can visualize all that in Flood Modeller, and I also can click on these to see the attributes associated with them all in the same place. I'm going to switch most of that off just to make it nice and clear, jump back into the results, and I'm going to put the depth data on. And if I fast forward a little bit into the simulation, I should get some flooding in a second. There we go. You can see the water starting to spill from the 1D model into the 2D. And what you'll notice also, if I click on the cross section here, as you change the time step, the water level in the cross section changes as well. When I release that, it'll update the 2D, so you can see what the water level in the 1D is doing at the same time as the 2D. And you can see this water flowing across the floodplain through this culvert, through this gap here, and you can jump into any of these locations and you can start to interact with that data. You can also start to query that data as well, so you can pull out 2D results. As we did earlier, you can also put comments on this. So you can see there's a gap here. So you can provide feedback to the modeler as you go. Jump out of comment mode. And this works for Flood Modeller models, TUFLOW models, estuary models, and linked models. Just before I jump into the next section, I'll just quickly show you a more complex TUFLOW only model. So this is a site in Australia, and this is where we've got a combination of estuary cross-section data and open channel networks. And again, as you could do with the Flood Modeller, you can click on the cross-section data in estuary and you can visualize that directly. So you can see the in-channel water levels, and as you scan across with the animation panner, you can see the change in water levels of that cross-section. Or in this case, if we click on the pipes, you can see what's happening within the pipes as well. You can see the change in water level over time within that pipe, as well as bringing on all the 2D results as well. So it's a really powerful way of interacting with your data. Hopefully that's given you a bit of an overview of what Flood Modeller platform can do. There's a huge amount more functionality, including model export, tracking, data management, which we can show you as well, but that's probably for a separate webinar. So just jumping back into the presentation, I'll show you what's coming next. So we've got a lot more in development. A lot of this is already well progressed. But this is what we'll be adding in the coming weeks and months. So the first thing we'll be adding is the ability to have contextual mapping within your software, within your interface. So this will be things like existing flood maps, existing flood outlines. So if you're in the UK, that could be the UK flood zone maps, or that could be the observed flood outlines. We're adding a load of post-processing tools to allow you to process your results into the desired outputs. That could be map edit format for EA projects, for example. And we're also adding some detailed QA tools. A lot of these are already built, but we're going to add them into the interface. And so for the UK, that'll be focused on the Environment Agency's non-real-time model review sheet. So when you upload a model, you can choose to automatically run QA tools over it, and that will check things like for glass walling. It'll check for conveyance curves in 1D models. It'll check for mismatch between 1D and 2D models. So that's really powerful to upload a model and instantly check it. That could be a model you've built or one built by someone else, and instantly you've got an audit trail. Other key things, as Richard said, is HEC-RAS and SWIM support, as well as our 3D mapping services, which will be an addition to the global viewer, which will be really impressive when it comes to communicating flood risk. Before I hand back to Richard to talk about some of the licensing and pricing elements, I just want to touch on a couple of case studies where Flood Platform has allowed us to undertake the project where previously we wouldn't be able to. Some of these are internal projects where we've used Flood Platform over the last couple of years, and one is looking at the version of Flood Platform which we've now launched. So this first one is Oxcam. So this is the Oxford-Cambridge Arc. This is a major UK government initiative to deliver some million homes and £100 billion worth of economic growth in that corridor between Oxford and Cambridge in the south of England. This is a major key project, but it has a challenge. There's a lot of flood risk in that area. So as part of those development aspirations, we need to introduce flood risk management control measures and infrastructure to enable that development. But you don't want to build things unnecessarily. You don't want to build flood walls 10, 20 years before houses or a road go in. You want to find that optimal balance between investment and build. So in order to do this, we need some 900 models, which will run 45,000 times to generate the input data required for this analysis. And that was all done in Flood Platform, including automated simulation setup, simulation running, and post-processing. It was all done within Flood Platform to enable us to generate the data for that analysis. And it was, without Flood Platform, we simply wouldn't be able to deliver that project on the scale, the ambition, or time or program that the client demanded. Another example where we're using Flood Platform live is Melbourne Water flood mapping studies. This is in Australia, where Melbourne Water is responsible for both the urban drainage network, but also the flood risk from rivers system. And so they're undertaking a major remap exercise to produce new flood maps for the whole of the catchment using hydraulic simulations over a very extensive geographic area. And if you've ever worked in Australia, you'll be aware that you need hundreds of simulations to consider different storm conditions as part of the hydrology. So where's Flood Platform helped? It's allowed us, where we're the supplier, to be delivering these hundreds and hundreds of thousands of models, to be able to run them within that elastic compute environment and to process them within days rather than taking weeks or months to run the simulations. We're also using Flood Platform to share the data with the clients, to move data backwards and forwards, and also catalog where models exist. So all these hundreds of models being produced, be able to identify them is critical. The final case study I want to touch on is the Thames remapping study. This is a project which Jacob's been awarded with our partner JBA to remap flood risk across the Thames estuary over the next couple of years. This is going to be one of the most challenging modelling projects in the UK, where we need to look at the flood risk to some 1.4 million people and £3 billion worth of assets. We've got 100 kilometres of highly complex estuary, including barriers such as the Thames Barrier, and this modelling data is needed to inform the investment in the flood risk management scheme of the Thames through to 2021. We're looking at running hundreds of thousands of simulations all through Flood Platform. Also, Flood Platform will be the environment where we'll host the data and enable client and stakeholder review, that ability to just log onto a website, find the model you're interested in, and look at the results in real time. It will save us shifting terabytes of data back and forth between organizations, and it should significantly save us time when it comes to model review and sign off by using those built-in quality assurance and model commenting tools. Put simply, we couldn't have delivered this project without Flood Platform. Hopefully that's given you an overview of what we can do with Flood Platform. Just pass back to Richard to talk a bit about pricing and licensing.
Thanks, Adam. Okay, I'm conscious of time, so I'll try and keep this brief, although it's important. So Flood Platform is available effectively in two flavors, core and advanced. The core version is at £225 per seat per month, and the advanced is 275 per seat per month, which has advanced features with it. In addition to your seat, you also need to buy the storage, like you do with many online platforms. It costs us to provide that storage. So you pay for the amount that you use. So between 1 and 25 terabytes, it's $13.83 per terabyte per month. And if you need more than that, there's possibilities of discounts available to you to get in touch. Then on top of that, you pay for the compute, and it's a bit like a taximeter. You put credit on your account, and you buy it in units of £1, and in up to £10,000. You pay as is, and you can get discounts above that. But to put this into context as to how much it costs for the compute, if you're doing maybe a GPU simulation, or a Flood Modeller or a Flood Modeller TUFLOW simulation using a GPU, and each simulation takes around 30 minutes, which is quite a long time for a GPU simulation. But you've got 100 of them to do. Typically, you'd be looking around £30 to do all of that. So you can get them all done within around 30 minutes, because you can scale up the compute to do it. Obviously, you need the licenses to go with it, but you can bring your TUFLOW licenses with you. And for those who are using Flood Modeller, you get unlimited Flood Modeller licenses as part of your seat. That's really it. There is also a viewer licenses. So with each, the core and the advanced, you get viewer licenses that you can use to share with people, which are free. Thanks, Adam. Next slide. To get you up and running fast, we're pretty experienced of providing technical support and training through our Flood Modeller, and we are have put in place similar arrangements for Flood Platform. So you can be pretty confident that it's going to be good and robust. To make sure that people are up and running very quickly, we're providing personalised onboarding and training once you first sign up. There's lots of step-by-step guidance built into the product to help you through it, and also some offline training. You get dedicated support team. We have a global support team from Australia, India, UK at the moment that provides you the coverage. So there's usually somebody available to help you. There's interactive training that you can use to make sure that you can upskill people. And we're pretty confident that the design of the user interface is pretty intuitive. So it's quite a low hurdle to jump over to get using this and using it efficiently. And then, of course, we're looking to continuously improve the product through new improvements to the software itself and the training material that goes with it, and everything that goes around it. So we're very confident that people will get up and running very quickly, and there's the support network there for you included in your price.